And also, we're going to learn how to harness that energy because energy can be neither created nor destroyed, only transferred. And when we understand how to do this, then we really understand how energy fully works. Just trying to move up real quick. There we go. All right. So let's get started. So when you are converting, you need two things. You need the number that you're converting, 450, and the conversion factor. And the conversion factor is a ratio or two numbers that are the same but in different forms equal to each other. So our ratio is 1 kilocal equals 1,000 calories. And this is important because we're converting calories to kilocal. So we need to figure out how many kilocalories are in, or how many kilocalories, yeah, are in a calorie. And essentially, 1 kilocalorie equals 1,000 calories. So mathematically, you would just go ahead and just do the math in your head. You probably multiply or divide, but there's a method to it that allows you to just whenever you have a unit and a unit conversion factor, you can solve it and be successful without overthinking. So let's go ahead and try it. So I'm gonna pretend that I have my calculator with me. You will just have to have yours, and I will present the type of math that is required, and then you will go ahead and just do the math yourself. All right. So we're gonna go through this worksheet, and then you all are going to be successful. Okay, that didn't make any difference. All right, so we have 450 cows, and I'm going to write it in abbreviation. And what you do is you put it in what we call a T-chart. A T-chart has four quadrants: one, two, three, four. And you're never going to use this one. So you can either put an X here, you can put a one there, but essentially you're not going to use the bottom quadrant. You're always going to use one, two, and four quadrant. And this part right here is important because this is where your conversion factor goes. And essentially, you're going to match the conversion unit with the 1 and 4. You're going to match them based off of what the conversion factor says. So essentially, you're looking at the unit outside of the number. That's why I say it's really important for you to write the unit, because if you don't know the unit, the conversion becomes confusing. So we're going from calories to kilocalories. I know that 1 kilocalorie equals 1,000 calories. I have 450 cals. I want this part to be identical to this one so it can cross out due to the math. So I put 1,000 because it has cal next to it. And then whatever is not there, I already used this one. I put the other one at the top. Now the rule is you're always going to look for the one. There's always a one in the conversion factor. If the one is at the top, always divide. If the one is at the bottom, make sure you write this down. You multiply. Okay? So just remember that, and then let's go ahead and do the math. The one is at the top, so we're going to divide 450 divided by 1,000, and so it's going to be 0.45 kilocalories. And it makes sense because kilocalorie is bigger than a calorie, so the number should get smaller as you convert to a bigger unit. Let's do another example. 2, we got 1,200 BTUs, and we want to convert that into calories. See, first you need to ask how many calories are in a BTU. And so 1 BTU is equivalent to 252 calories or calories. And so I write out what I'm presenting or converting. Don't forget to write the unit. You write the T-chart. You don't have to put the numbers if you know you have four quadrants. This one is not usable. You can put the X or 1 there, and you're trying to match the conversion factor with the number you're converting, the unit with the unit you're converting. So I have BTU here, so I put BTU here, and I look for the number that has that, the 1. And there goes that 1 again. The non-1 number goes at the top because the 1 is at the bottom. I know I did this right because it crosses out, and this time the 1 is at the bottom, and we said that when that happens, we multiply. If the 1 is at the top, we're going to divide. So that's going to be a big number, 302,400 calories. And it makes sense, right? Because BTU is larger than a cal. So if I have a lot of BTUs, that means I'm going to have a lot of calories because calories are smaller. That's how you know if you're doing it correctly. Excuse my handwriting. And 1 horsepower power HPH, that's equal to 2,555 BTUs. Now this question is easy because it's asking you how many BTUs in uh 1 horsepower per hour, and we just have a 1, so obviously it equals 2,555 BTUs. But to do it mathematically, right? This is still the conversion factor. We're just doing 1. So same thing. And we know anything divided by 1 is itself. And so essentially, when doing US customary unit conversions, you need to know 3 things. Use the T chart and know you have 4 quadrants. You only use 1, 2, and 4, never the third one. Replace it with X or 1. This is math, so there could be a multiplication sign there. It could be a division sign there. I mean, the division sign is already kind of here. You just can't really see it. You see it? So the equal sign also goes here. And we are converting between things that are equal, but just in different forms. So all you're doing is just changing things, okay? So remember, if the 1 is at the bottom, there's always going to be a 1. If the 1 is at the bottom, you multiply. If the 1 is at the top, you're going to divide. Let's go ahead and go to part 2.